Well, we've now completed Chapter 4, which is a study of vectors, and vectors are the primary data structure in R. This new chapter here, Chapter 5, moves up to matrices, which are two-dimensional equivalents of a vector. And here's the definition of a matrix. A matrix is a rectangular arrangement of numbers. When you refer to the elements of a matrix, the first subscript will give you the row number, and the second subscript will give you the column number. One thing that's a little bit unusual about matrices in R is they're stored column-wise. In most languages, they are stored row-wise. The origins of R were basically statistical analysis, and there are some good reasons why R uses columns to store matrices. A lot of that, though, will be transparent to you, as we'll see going forward. There are three different ways of creating a matrix. The first is the matrix function. The syntax for the matrix function is, first of all, matrix, and then the first element or the first argument to the matrix function will be data. And there is NA will be the default for data, but usually you'll be putting numbers of some kind in there. The second argument is the number of rows in the matrix, and the default on that will be 1. The third argument will be the number of columns, and that will default to 1. And then there is a by row argument, and that defaults to false because, as I mentioned a minute ago, R puts them in column-wise. So let's do a quick example of this. We're going to define a matrix, and the first thing we want to do is put in the data. And you'll notice that right above this in yellow, it will actually tell you what the arguments are. So this isn't something you have to memorize. In RStudio, this will pop right up, and it'll remind you what the arguments are. So for our data, let's just put in 1, 2, 3, 4, 5, and 6. That is, put a vector in. And the second thing, let's set the number of rows to 2 and the number of columns to 3 and see what we get. So there is a matrix, and what you can see is it has 3 columns, as we asked for. It has 2 rows, and here are the row labels, 1 and 2. And it also has 6 entries. And in those entries, again stored column-wise, are 1, 2, 3, 4, 5, and 6. So by default, they go in column-wise. And so if I wanted to put them in row-wise, here's how I do it. I'd go 1 through 6, and then I would put in my 2 rows. And by the way, this time when I put in 2, 3, I'm saying that the number of rows is 2 and the number of columns is 3, just as above. But this time I'm using the position of the argument rather than actually naming it. And then I'll throw in the by row equals true argument. And this time our matrix will go in row-wise. 1, 2, 3 for the first row, 4, 5, 6 for the second row. Give you a quick example of some recycling here. If we want a matrix and put zeros in, and let's say we want to make this a 4 by 3 matrix, that's how you would do that. Now it's asking for 12 elements, and we only gave it the 0, but once again, R will recycle, and you will get a 4-row, 3-column matrix of all zeros. Give you another real quick example here. If instead of putting in a 0, we had put in, for example, 1:3, what it would do there is it would recycle the vector 1, 2, 3, put it in column-wise, and you can see you would get the matrix that is displayed here. Now that's the first way to define a matrix. There is a second way of defining a matrix, and that is the R-bind function. And that stands for row bind. As an example of the R-bind function, we could say R-bind the vectors 1:4, 2:5, and 3:6. In this case, it has three vectors as arguments, and they are the vectors 1, 2, 3, 4, 2, 3, 4, 5, and 3, 4, 5, 6. And when you bind those together as rows, you get the following 3-row and 4-column matrix, and you can see the arguments there appear as rows. Probably have the hang of recycling by now, but let's just try another example. We could say 1:12, take that row and attach this row to it. Now, all matrices are rectangular, which means we have our first row having 12 elements and our second row having 4 elements, and you know that R won't have that. So what it's going to do is it is going to recycle that vector of 1, 2, 3, and 4. It's going to recycle that 3 times in the second row, and there's what you get. You can see 1 through 12 in the first row, and then 1, 2, 3, 4 gets recycled 3 times in the second row. Let's do another quick example. This time we're going to use the cbind function. And this time, of course, we'll be binding together columns. So I will have a vector x, which is set to perhaps 3:5. That will be one of the columns. And then I'll set a vector y. We'll also give it the same dimension, so we'll go 7:9. And then the matrix B will be taking those 2 columns and binding them together. So x and y will get bound together, giving the matrix Z. So if you look up here, notice that x is 3, 4, 5, y is 7, 8, 9, and then here is Z, which is a matrix. And because it's a matrix, notice it has 2 subscripts rather than the 1 subscript for a vector. And let's take a look at Z and see what it looks like. Now, one thing you'll notice right away with this is it is, first of all, a 3x2 matrix, as it should be, because the first column had 3 elements, 3, 4, and 5. The second column had 3 elements, 7, 8, and 9. But you get this time labels, that is, column labels. X and Y got inherited from the arguments here, as opposed to the more generic column headings that we see for the 2 previous matrices. That ends the discussion of how to create a matrix. There are 3 ways to do it. One is with the matrix function. The second is with the R-bind or row bind function. And the third is with the cbind function or column bind function. In the next clip here, we're going to see how you extract or index the elements of a matrix.